Okay, everyone, we are on question 4 here, May 2016, the most recent paper in C2, Core Mathematics C2 AS level. The question says you've been given a polynomial. That polynomial, fancy term for lots of different forms of x inside that expression. So we've got 6x cubed plus 13x squared minus 4. Whenever you hear the term polynomial, don't get stressed. All it means is that you'll have multiple things in there, constants, you'll have x's. In this case, we don't have an x, which means that the constant behind x would have been a 0. And here we have an x squared term and an x cubed term. So anything that is a polynomial has multiple degrees of x in it. That's all polynomial means. You've been given this polynomial. It's called f of x equals 6x cubed plus 13x squared minus 4. Before you do anything, it's almost impossible for you to get away with this question without having to rewrite that polynomial again at some point. So we'll save ourselves the trouble and rewrite that polynomial right here. 6x cubed plus 3x squared minus 4. I hope I've copied it over correctly. I have. The first part of the question, 4a, says use the remainder theorem to find the remainder when f of x is divided by 2x plus 3. Before we continue, take a look at a few things. It says you have 2 marks, therefore it's probably something short and simple. It also says use the remainder theorem. I can't even begin to describe how many people don't follow instructions for this very simple 2-mark question in examinations. Examiner reports galore state with examiners pulling their hair out saying use the remainder theorem means use the remainder theorem. It doesn't mean long division. Unfortunately, a lot of students tend to get right through this question with long division. They get the right answer, but they get 0 marks. That's because basically they didn't follow instructions. So when it says use the remainder theorem, don't use long division. Very simple and something that's been referenced time and time again in examiners' reports. Now, what is the remainder theorem? Firstly, it's a lot easier than long division. Let me quickly show you what the remainder theorem is all about. The remainder theorem. I should really abbreviate these things. They take a long time to write on these blackboards. The remainder theorem, we shall now abbreviate that as RT, basically says if you have a polynomial, let's call that f of x, if it is divided by anything that resembles ax minus b, then bring in fancy stylus moving the screen around. Ax minus b, then you may find the remainder, we shall call that r, by simply substituting b over a back into the original expression. That's your remainder theorem. You don't have to go long division. You don't have to do anything of the sort. All you need to remember is this very simple theorem that states if f of x is divided by ax minus b looking things, then you may find the remainder by simply inserting b over a back into the equation. The equation was 6x cubed plus 13x squared minus 4. Therefore, the first part of this answer will require us to take a look at that divided by, which is 2x plus 3. Therefore, 2x plus 3, does it resemble ax minus b? Yes, it does. And what are those individual components? Well, a, as you can see, is 2. And b, which has a minus sign before it, but the one inside the bracket in the question has a plus sign before it. Therefore, this must actually have been 2x minus 3 in order for us to get that plus sign to begin with. Therefore, excuse the scribble, b must equal minus 3 in order for us to proceed with this question. Therefore, f of negative 3 over 2 is what we need to find in order to answer this question by the remainder theorem. Using the remainder theorem now, as I've explained it, it may sound fairly lengthy, but I'm explaining how you should go about doing it. You won't need to explain to yourself how you go about doing it. Therefore, in the examination, it should take you a lot shorter a period of time to answer this question. And now we shall proceed to answer the question. here we are. F of minus 3 over 2 simply inserted back into the question. That gives you minus 3 over 2 cubed, because we have 6x squared, plus 13x squared, 6x cubed plus 13x squared. X to be substituted in negative 3 over 2 squared, and then you simply have a minus 4 as your constant. Move along and start solving. Remember, this is C2. You are allowed to use a calculator. However, presenting it on the screen, it is hard for me to show you the calculator on screen, so I'll go ahead and do it the old-fashioned way when we didn't have calculators back in the day. And we shall solve it rather quickly. It's a good exercise for you too. If you're good with numbers like that, it should take you fairly little time to go ahead and do these things. Negative 3 cubed is negative 27. 2 cubed is 8 plus 13. Negative 3 squared is 9 over 2 squared, which is 4 minus 4 again. Move along. Notice that 8 and 4 have a common factor, and that factor is 4. Therefore, it probably will suit me if I have everything lined up with 4 as the common denominator. So I notice here that 6 over 8 can be simplified to 3 over 4 because they both have 2 in common. Therefore, negative 27 times 3 is how much? Negative 27 times 3 is negative 81 over 4 plus 13 times 9, 9, 3, 27, 2, 117 over 4, and minus 4. Keep moving along. Remember, this is C2. You have a calculator in the exam. I can't show you a calculator on screen, therefore much more difficult for me to do so with a calculator than not. Negative 81 over 4 plus 117 is basically negative 81 plus 117 over 4, the whole thing minus 4. Moving along, that gives me 36 when I add negative 81 and 117, 36 over 4 minus 4, which translates to 9 minus 4, which equals 5. Therefore, f of negative 3 over 2 equals 5, and there you have it. You have your remainder using the remainder theorem. Alrighty then, moving along to part B of the question, which is use the factor theorem. By the way, that's even easier. When you've got a factor like this, use the factor theorem to show that x plus 2 is a factor of f of x. Now, again, warning like I did in 4a, please, please, please do not use long division for any reason whatsoever because the question does not ask you for it. Use the factor theorem to show that x plus 2 is a factor of f of x. Also notice that it is 2 marks in value, therefore it must be short and sweet. Going over to our slide again, we scroll up, make room for part B. For part B, the factor theorem states that if f of x has a factor x minus a, then substituting that value a into the factor, into the expression, will give you a0. So the question says x plus 2 is a factor of f of x. Therefore, x plus 2, if it is a factor of f of x, then x equals minus 2 when substituted into the expression f of x equals 6x cubed plus 13x squared minus 4. If we were to put in minus 2 in here, we would get a 0. That's what the factor theorem states. Therefore, f of minus 2 should give us 6 minus 2 cubed plus 13 minus 2 squared minus 4. Continue on. Again, this is C2. You do have a calculator. I don't have that luxury on screen as I'm on a screen. Hard to show you a calculator when I'm doing so. So I'll go the old-fashioned way. Minus 2 cubed is minus 8 plus 13. Negative 2 squared is 4. The whole thing minus 4. Negative 48 plus 52 minus 4. And as you can see, negative 48 plus negative 4 is negative 52 plus 52, which, as you know, adds up to 0. And there you have it. That is part B. You've proven that x plus 2 is indeed a factor of f of x. And finally, we come to part C of this question, which says factorize f of x completely. First thing to notice, it hasn't told you what exactly it would like you to factorize it with. Therefore, you have complete and utter flexibility of going about doing this. You could use long division, you could use algebraic manipulation. I would suggest you use long division, as that is going to be the shorter route. The question hasn't stipulated what you should use, therefore you're free to do so. If you use the algebraic version, it'll be a lot more working for the same number of marks, so be smart, be skillful. You know long division, you know the factor theorem, you know the remainder theorem, both of those have been used. Factorize f of x completely. You've also been told that the x plus 2 is a factor of f of x. That makes things even simpler. So what we'll go ahead and do is use, let me stay on the slide here, use x plus 2. Knowing that it is a factor of f of x, we know that the remainder will be 0, but at least by doing long division, we'll get the quadratic equation that we need. And I'll just, before I go ahead and confuse some people watching this, let me quickly tell you why quadratic. Notice that 6x cubed. X cubed is a term in this equation, and one of the x's has been provided to you. X plus 2 is a factor. Therefore, there must be an x squared somewhere that you need to multiply x with to get this x cubed. Therefore, it's going to say, you're going to say there are 3 factors, x plus 2 and 2 others. Because you have 2 others, you need to have a quadratic equation with an x squared term to give you those 2 factors. Very, very simple. Let's go over to our slide here, scroll up using fancy stylus to part C. Remember, x plus 2 is already a factor. We know that the remainder will be 0 when we divide 6x cubed plus 13x squared minus 4 using long division by x plus 2. We know the remainder will be 0. We're not interested in the remainder. We are interested in what appears at the top. We are interested in the quotient. So, starting with x, x goes how many times into 6x cubed? It goes 6x squared times. And when you multiply 2 by 6x squared, you get 12x squared. So, plus 12x squared comes down here. Forgot to write the 6x cubed we did earlier, so x times 6x squared gives us 6x cubed. Now we subtract. So moving screen along, 6x cubed minus 6x cubed is of course 0. 13x squared minus 12x squared gives us plus x squared, and we simply bring down the minus 4, rinse and repeat. X goes how many times into x squared? It goes x times, so that's plus x up here. And an x squared down here, and plus 2 times x gives us plus 2x over here, and nothing else. So again, subtracting x squared minus x squared equals 0. There is no x term on the top. 0 minus 2x gives us minus 2x, and we simply bring down the minus 4 as there's nothing below, no constant below to subtract with. Minus 2x minus 4 is all we've got. X goes minus 2 times into 2x, so we write minus 2 up here. X goes minus 2 times into minus 2x, giving us minus 2x, and 2 goes minus 2 times to give us minus 4 over here. We simply subtract minus 2 minus minus 2x is minus 2x plus 2x, therefore that cancels out to a 0. Minus 4 minus minus 4 is minus 4 plus 4, which also gives us a 0, which we knew because we know this is a factor, so the remainder is a 0, but what we wanted out of this exercise was Mr. Quotient. So, big squiggly line over Mr. Quotient, we now have the quadratic equation 6x squared plus x minus 2 alongside our original factor x plus 2, 6x squared plus x minus 2. Let's quickly double check that over there, 6x squared plus x minus 2. Therefore, we are now in a unique position to go ahead and find the remaining factors. Remember, part 4c says factorize f of x completely. Therefore, we have now rewritten f of x as x plus 2 6x squared plus x minus 2. Again, the question has not told you has not advised you of any particular method to use, so we are free to factorize 6x squared plus x minus 2 however we like. The easiest way is to simply use the quadratic formula. Many calculators have the quadratic formula built in these days. Back in my day, we didn't have such a luxury. And on these sessions, I don't have this luxury of using calculators unless absolutely necessary in future lessons where we'll be doing trigonometry and using sine, cosine, and other logarithmic situations that will require the use of a calculator for ease of use. But for now, I shall go the old-fashioned route: x equals minus b plus minus square root of b squared minus 4ac over 2a. So we know 6x squared plus x minus 2. Let's double check that. Yes, indeed. We know a equals 6, we know b equals 1, and we know c equals minus 2. So, therefore, x equals minus b minus 1 plus minus square root of b squared minus 4 into a, which is 6, c, which is minus 2, the whole thing over 2a. We know a is 6. Solving this, we get minus 1 plus minus the square root of 1 squared, which is 1, plus 4 times 6, 24, 24 times 2, 48. You know where this is going. You don't really need a calculator for this. The moment you see that, you know we are looking at very simple square roots here. So minus 1 plus minus the square root of 49 over 12 gives us x equals minus 1 plus minus square root of 49, 7 over 12, which gives us two possible values of x: minus 1 plus 7 over 12 and minus 1 minus 7 over 12. Both of these turn into minus 1 plus 7 is 6 over 12, and negative 1, negative 7 is negative 8 over 12. We will simplify this further. 6 over 12, as we know, simplifies to 1 over 2, as 6 factorizes into 12 twice, and negative 8 over 12, 4 goes twice into 8, and thrice into 12 gives us negative 2 over 3. Now we therefore have x plus 2 as a factor, therefore x equals minus 2, 1 over 2, and negative 2 over 3. Now, in order for us to state the final factorized equation, which is x plus 2, and a quadratic equation, we need to rewrite these factors 1 over 2 and negative 2 over 3 as factors looking like x plus 2. That's what the examiner would like from you. Therefore, we know x equals 1 over 2. Therefore, 2x must equal 1 going across, and therefore 2x minus 1 equals 0. There we have the second factor. And the third factor will come from negative 2 over 3. We also know that x equals negative 2 over 3. Therefore, 3x must equal negative 2. That's when you take 3 over to the other side, eradicate the denominator, multiply the entire thing by 3. 3x and minus 2 over 3 times 3 is simply minus 2. Therefore, 3x plus 2 equals 0. We now have three factors. F of x, therefore, factorized completely looks like x plus 2, 2x minus 1, and 3x plus 2. Technical issues. Let's rewrite that again. Equals x plus 2, 2x minus 1, and 3x plus 2. Much nicer, much neater. And there you have it, folks. We have solved the question. all parts A, B, and C using exactly what the examiner asked us to do. We used the remainder theorem for part 1. F B over A is used to solve that question. Use the factor theorem to show that x plus 2 is a factor of f of x. Here we substituted in minus 2 into the equation to give us an answer 0. That's what we had to show. A factor x plus 2 would be a factor if when minus 2 substituted into f of x gives us a 0, which we found. And factorizing f of x completely, we weren't told exactly what to use, therefore we went with a few approaches. We followed long division to get the initial quadratic equation. We then factorized that quadratic equation using the quadratic formula, arrived at two additional values of x, after which we used those values to construct factors that we then used to rewrite the original complicated looking equation into a much neater factorized equation, which is what the examiner wanted.